So 2.5. Number 35, right?
Yes.
Says a rocket is divided into 3 sections. So you got the top section, the middle section, and the aft section, I'm going to presume. Ooh, this is going. So they got top, middle, bottom. You guys like my rocket? Let's give it some. And you stick them together and you throw it up into space. And you pray. The top section is 1/6 the length of the bottom. The middle section is 1/2 the length of the bottom. So which one should I start with? Which one's going to be just X? The bottom, because the other ones depend on it. So if I call the bottom B or X, let's call it B just to be different. The top is 1/6 that. Well, yes, 1/6 that. And what else did it say? The middle is 1/2 that. So 1/2 B. And then they say the total length is 240 feet. What do I do with them then? Add them all up to make 240. There are fractions in here, so if you want to, you make everything have the same denominator and then clear them. If you want to. I might not do that if I were you. Watch what happens. So what's the LCD right now? 12. LCD is always a number bigger than the denominators, right? Normally, because it's got to be something they both become, not what goes into them. But what do you get when you add these together? How do I add these together? What do I need here to add these together? Yeah, multiply by 3. So I got 1/6 plus 3/6. Right? 1/6 plus 3/6? 1/6 plus 3/6. 1/6 plus 3/6 is 4/6. And you see how that reduces? So that's 2/3. So now if I just multiply everything by 3. That wasn't that difficult, and I can still clear this fraction if I want to, and the bottom is a lot smaller than it was. It used to be 12, now it's 3. Right? There's several ways to do that. You can clear the fraction if you want to. You don't have to. You can just work with them. You could get these together now. This is like 1/1. You can make LCD, get those together. Is that decent?
So you don't need to know the LCD really? When you try to get one of the fractions to like with the same.
So from year to year, I had to figure out the LCD, right?
Yes.
Or I could do an LCD for the whole thing, which would have been, I don't know why I said 12. It would have been 6, but that's all right. But now that it's a little bit better. And that wasn't that difficult to put those together. Who asked that question? Is that a decent place to stop? Does that get you past where you got stuck? Okay. So now you got multiple ways to do it. You could put these together. You could multiply each thing by 3. Do you see how that would kill your only fraction? So you could do that if you want to. If you multiply each thing by 3, that's now the 2b plus 3b equals 720. Look, you're a couple steps away. Yeah.
On 55.
Is everybody cool with that one? That's 35. That's the rocket problem. Okay, 55?
55, I saw the pattern for like each level went up 70 points, but I didn't know how to translate that to.
So this is the one that's like 1, 200, and 2, 270. And then they go up from there. Right? So and this is the level and the points. Level and the points. So you figured out that the points go up 70 for every 1 that the level goes up, right? All right, so one way you can do this is the points would equal, do the points equal 70 times L? No. Right? So here, the points are 200 when the level is 1. Then they're 270 when the level is 2. So what would kind of like 0 be? Can you guys see what 0 would be? If you go up 70 this way, you go, yeah, so 0 would actually be 130. So now watch why that's cool. The points would then be 130 plus. Because here it's not 0. It's not 70 times 0. That would be 0. But you start with 130 points. And then every time you add another level, you add 70. So you start at 130. And if you got level 1, now you add 70. Level 2, you add 2 70s. Level 3, you add 3 70s. So level X, you add X 70s. So this will be 130 plus 70X. That problem is actually a precursor to linear equations, mx plus b stuff. If you guys remember anything about slope, that's actually the slope we just figured out. And that's the y-intercept. If you don't remember that stuff, it's in our future. Don't worry. But if you know that, this problem actually is a little bit easier because you can just put it into that context. Now, this problem is one of the harder ones in this section. So if this is one of the few you had trouble with, you're doing fine. If it's one of the many you had trouble with, maybe you should see me or something. Anything else from that section? Have you guys tried those yet? Can't help you much if you haven't tried it.
Number 60.
60? Oh, okay. So 60 is the one about Robert taking a drive through the mountains. We're like, Robert, just stay home, man. Don't be making problems. He drove for 6 hours on a level highway and then for 2 more hours through the mountains. So 6 hours, level highway, and then 2 more hours in the slight mountains. His speed through the mountains was 20 miles an hour slower than his speed on the first part of the trip. Oh, shit. So my unknowns are his speeds through this various. So his speed through the mountains was 20 miles an hour slower than the speed on the first part of the trip. So I got speed first part of the trip, and then I got speed through the mountains. So the speed through the mountains was 20 miles an hour less, which makes sense, than the first. So which one is going to be just X? Which one does the other one depend on? Yes, that I can call this one X. Why? The speed through the mountains was 20 less than this dude. I better know this dude before I subtract 20 from him. I gotta know this guy first. You start to see how to figure out what's X. It's what the other thing or things depends on. If I call this X, this has got to be what? It's 20 less than the first. X minus 20. Of course you slow down the mountains. Especially if you had my old car. that was barely make it up the mountains. And then we went this way. We were going to see a friend up at JMU when I lived in Virginia. Barely made it up. And then we went the other way. I'm like standing on the brake. Oh! And I said, well, let's go the non-scenic way back. Sounds good. All right. So we got a lot of stuff going on here, right? We got time for each. We got expressions for speeds, right? And then the question is, if he drove 300 miles longer on the level road than he did through the mountains, how fast did he drive? Now, all right, so these two are definitely some of the harder ones. Who knows the formula relating distance, rate, and time?
Distance equals rate times time?
Yeah, yes.
V equals dt.
Well, okay, so, yeah, what'd you say right here? D equals V?
V.
Ooh, I love it. Okay, so V for velocity, right? I like it. In general, we say R for rate, but V for velocity is kick-ass. I like it. Yes. You good? All right. This is the dirt equation. D equals RT, dirt. Or not, whatever works. Right? You do this all the time. You're going 80 miles an hour for a couple hours. How far did you go? 160. I mean, you're driving somewhere. You have to be able to figure out how fast do I have to go so I can get there. Some of you guys are just like, I'll go as fast as I can. If we get there early, I'll just hang out. But this is the formula relating everything. Right? What is it that I know? What is this?
8 hours slack.
Yeah, this is time, this is time. This is rate, this is rate, this is rate. So for each situation, what's the distance I went here? Now watch. Distance is rate times time. So how far did I go here? I went for 6 hours, I was going X mile an hour. If you're going 20 mile an hour for 6 hours, how far would you make it? 20 mile an hour. So it's going home at 3:30 in the wrong direction, right? Sometimes you just stay where you are here. But so if I'm going 20 mile an hour for 6 hours, how far did I go? 120 miles. Of course it is. That's why it's distance equals rate times time. Velocity times how long you go that speed. So what is it here? What's the time in the flat land? 6. And what's the velocity? What's the speed? X. Rate times time. Rate times time. 6x. Rate times time. What's the distance over here? Again, it's rate times time. Always. Yeah, x minus 20 times 2. Now this is definitely, again, these are the last two problems I think. I can't remember. They're a little bit more. But again, it was this basic definition of what distance is in terms of rate and time. They tell you the times. They give you a way to write the speeds. And then you multiply them. So the distance he went here is this.
They gave you the distance.
They gave you the total distance.
Oh,
So what's got to be true then? If the total distance he went was, where'd he go? Oh, actually they didn't give you total distance. They gave you a relationship, right? He drove 300 miles longer on the level road than he did through the mountains. So this is 300 miles longer than that.
so plus 200.
Which is plus, yeah, so this is this plus 300. The distance he went on the flat is 300 more than the distance he went in the mountains. Now think about it. Why does it make sense? Because he went for less time at a slower speed. So of course he went a lot less distance through the mountains than he did on the flat land. So that kind of makes... Now this is the equation. You solve the equation. You distribute. Solve the good old equation. That definitely was one of the harder ones. I don't blame you if you had trouble with that one. Well, now you solve it. I got to leave something for you. So now you solve it. Make sure you answer the whole thing. So those two at the end definitely were the worst ones. So that's nice that I'm getting questions on those. I would expect to. I get worried sometimes when there's problems I don't get questions about. I'm like, is anybody doing it?
Does it ask for both speeds or?
Yeah, it asks for how fast did he drive through the mountains. So they really just need to know that. So once you get X, is that the answer?
No.
You got to subtract 20 from it to get that answer, yeah. I like it. Again, if you haven't tried these yet, and you're a little bit like, holy shit, this is one of the harder problems in that section. If the 55 and the 60 are the only two you had trouble with, real trouble with, then you're doing fine. So hopefully the earlier ones were okay. Anything else from that section, 2.5? I like it. All right. Okay, so let's do inequalities. We'll do a little graphing, and then we'll call it a day. Yes?
You're going for chapter 3 right now, right?
Not yet. We still got to do 2.6. So inequalities, and then some graphing. Just so you realize what's happening next Tuesday. Monday's a holiday. Tuesday I'll have a practice test. We'll finish up as much as we can. We're not going to go all the way through 3. Don't freak out. There's no way in hell. So I'm hoping right now we'll get to 3-4 maybe. Right? But on Monday we'll know exactly what the test is going to cover. It's not going to cover all of chapter 3. There's no way. Some of you guys should realize that. Right? Everybody with me? So on Tuesday I'll have a practice test I'll give out. We'll do as much of 3 as we can. Wednesday I'll have the answer key for the practice test. Wednesday will be nothing but review. There won't be anything new. Thursday will be the test. That's what's happening next week. Okay. So we did a little bit of inequality stuff. I tried to show you one of the only differences with solving inequalities is when negatives are divided or multiplied, right? So just remind me, how would I solve this? Divide by negative 1, and of course what happens then? That flips. And we talked about why that's true. It's one of my favorite answers. The answer is because that's how numbers work. Right. When you multiply divide by negative, you change the side of 0 you're on, so everything that was bigger is now smaller, and vice versa. It's just the way numbers work. I like it. Now, how do I graph this? I don't need y and x. I only got x. I just need the one number line.
So it would be a straight line. Oh, my bad.
Don't think too far ahead. We're not doing x and y yet.
So from -5 to
Yeah, so I definitely want to put -5 down there. Don't give me like 20 tick marks, and you don't have to do that. Please, dear God. Just stuff around the one I'm curious about. Now, be careful now. This is going to be a little different. What do you put on the -5?
a circle.
Say again? Closed circle. Why would you put a closed circle? Yes, and now I'm going to tell you don't do that anymore. Where you closed circle because you want to include it, right? You put this with a capital I. Closed circle means include it. Why do you want to include it? Because it says it's allowed to... How do you read this off? Less than or equal to. It's allowed to equal this. So I want to include -5. So a shaded circle makes sense because I shade where the answers are. If I didn't want to include it, if that wasn't there, it would be open circle. I like it. So this is the old way of doing things. Here is the better way to do things. And it is better. You're not going to believe me, but too bad. If you want to include it, do you see that's the letter I for include? Use a bracket. Looks like part of the letter I. So instead of a closed circle, we're going to use a bracket. So this would look like this. Which way am I going to shade? It points you in the direction. You got to love that shit. If the variable's on this side, this points you in the direction you're going to shade. A little arrow. So I want to shade this way. So on -5, I would put a bracket. You see how it opens the way. I always used to joke. I think I said something about Dragon Ball before. Nobody reacted, but Kamehameha. See? Just like that. So, and then shading is the... You have no idea what Dragon Ball is. Just, I don't know how to help you. But this always opens the direction you shade, is the short story. The non-anime story. Right. How would I write... Now, so if it was less than -5. Look, it's a circle, right? So you would use a parenthesis instead. Okay, and I'm going to show you why. It's not just because we went, let's screw with them. No, there's a reason. So here's -5. I would use a parenthesis. That means don't include -5. Because is -5 less than -5? No. Right? So I don't want to include it. That's what that symbol means. It's like a big open circle that lost half of itself. Right? That's a way to remember which one to use. So why do we do that weird shit? What is the smallest value x could be here?
Infinity.
What kind of infinity?
Negative.
So it goes from -infinity up to -5. I want to include -5. See the symbol? I just copy it right there. Infinity, I cannot ever include infinity. You don't put a bracket on infinity. Why do I include -5? Because I can get to -5. Look, there it is. Where's -infinity? Can I get there? It's never happening. It's not a number. It's a process. Start to go down, now continue forever. There you go. That's -infinity. You can't get there, right? If you get there, it's probably nirvana and you go to the next level. And shit. Not the band, but the actual nirvana. Okay. So you always put a parenthesis because you can't get to infinity. Has anybody ever seen this notation? It's called interval notation because it's an interval of values. So the only difference between this one and the other one over there is this would still be negative infinity, but then it would just not include negative 5. It would be the same symbol there. Yay. So I ask you to solve inequalities, graph the answer, give the answer in interval notation. Ask of those three things. All right, so let's do another one. Let's do one where you have to actually solve a little bit. Yeah, there you go. Good job. So this is pretty straightforward. You solve just like you solve equations. It's only if you multiply or divide by negative you got to worry about changing something, changing that sign. So what's the first thing you would do here? You add 1. Divide by 4. So what's it going to look like graphically? Yeah, so it's going to be a bracket. I like it. You guys are like, I don't watch that. Stop doing it. And then interval notation will look like what? Interval notation is always smallest comma biggest. So what's the smallest x could be?
2.
2. And what symbol's on the 2?
Bracket.
Brackets, you know, oh well. And then all the way up to infinity, parentheses. Because if I put a bracket on there, I'm going to ask you to show me infinity. And you're going to go, here it is. It's going to freak me out. I think that's what's in the briefcase in Pulp Fiction. Is that somebody else was thinking the same? Infinity. Whoa.
You know, Einstein said if you travel long enough on infinity, you come back on yourself.
Dude,
So this
that's
guy
the
tried
movie
too hard.
Paycheck. The movie Paycheck.
He
If
got
you ever
tried
watched
too
it.
hard, and he wound up on the street, and he woke up in the morning and stumbles into a Starbucks to kind of wake up. So he goes outside, he goes to the curb, he looks across the street, sees another Starbucks, he goes, Einstein was right.
Oh, God. Of course, Einstein didn't live in a time of the Starbucks on every corner.
Yeah.
But there's a Starbucks opened up inside that Starbucks. Let me see. Here, you guys try this one by yourself. Let's- I like it. It's nice and gross. So solve it, graph it, interval notation it. So the solving part, for the most part, is the same exact thing as solving equations. What would you do first? Subtract 7. I like it. Get the thing with your x in it by itself. So what do you get here? Negative 10. Divide by negative 5.
So the X is 2. Oh, I'm sorry, yeah.
I like it. Not because of that negative, but because that. We divided by a negative. Not just there was a negative somewhere. Now, how'd you guys graph this?
C on two.
Parenthesis. And which way are you going to shape it? Okay. Why is it not a bracket? Because a bracket would mean it's an I for include. I don't want to include 2. 2 is not less than 2, so 2 is not an answer to this. Is 1 less than 2? Hell yeah, that's why it's shaded. Right? So you can check real quick, make sure something over here that you shaded actually works. Because that's what you're saying is everything I shaded works. That's what you're saying.
So
And then interval notation,
it's bracket infinity 2.
never bracket, parentheses.
I mean, parentheses is what I meant.
What kind of infinity?
Infinity, negative infinity, 2 parentheses.
Parentheses. I know you're all like, I'm calling the parentheses brackets, just deal with it. Yes? Because where's infinity? Where's positive infinity? That way. Now these are all negatives down here, so eventually you get really, really big negative. That's negative infinity. I like it. Yes?
In interval notation, is one of them always going to be infinity?
Great question. It's like I planted you out there. So watch this problem.
What was the question?
The question was, will one of these always be infinity of some kind? So far they have been because it wasn't bounded. So if I say x is less than 2, well, it can go forever in one direction. There's no floor in this case. You guys see that? There's no floor in the answer. So there's a ceiling. There ain't no floor. It can go down forever. So what kind of problem would have a floor and a ceiling? Well, it's going to have numbers on both sides of x. Oh, shit. So like negative 4 less than x less than or equal to 7. And a better way to read that is, this is all the values of x that are between negative 4 and 7, including 7. You see how the between, this is totally a between idea. So it's going to be a sandwich. Yes? You don't have to separate it. No, don't. In fact, it's a bad idea to separate it. So the answers are going to lie between what two numbers? Negative 4 and 7. 11. So I'm not worried about, I hope to God you know this is negative 3 and negative, so don't write that shit. Just make sure you put those on the right side of each other. Right? What goes on the negative 4? Parentheses. Now watch this. People look at that and they say, oh, I'm going to shade down. No. Read that. X is bigger than negative 4. Isn't that what that says? Is the variable on the correct side in that little piece? No. That's why it's the opposite. But it's between. That's all you got to remember. So what goes on the negative 4? Parentheses. Which one of those is negative 4 now? Parentheses. What goes on the 7? Bracket. And then you put in the jelly. Right? I call it a sandwich. Okay, cool. I like it. 2 different kinds of bread. With some nice strawberry jam. Or whatever you like.
So parentheses, negative 4,
Good.
7.
I like it.
So
So this is really nice. Now that we don't have those circles anymore, the answer is basically staring me in the face. That, negative 4, comma, 7, that. Bam. So that's one reason why we like go over the circles, because it matches up with this. And you see how that's like the best notation. That's the quickest way to say it. That takes a little while. That's like bam. So this is better notation, so we brought those symbols on there just so they match. That's why we let go of the circles. So if you love the circles, get over the circles. Right. Okay? Let's see. Blah, 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 blah. There's not much else they could do to you. How do you solve, let's see. One last question with this stuff, and then we'll get a little bit into graphing. It's not going to look like, see how this is solved already? Some of you guys might be like, what the hell would it look like if it wasn't solved yet? Well, here we go. It would look like this. I like it. Now watch. This is kind of cool. Over here, what was on the earlier question, what was the first thing we did? Added something to both sides or whatever, right? So here, if that was the problem, what would you do first? Add 1 to both sides. So you add 1 to all sides. Add 1 to all sides. In fact, we always do the same thing to all sides, but normally there's just 2 sides. But the general rule is do the same thing to all sides. There's a left side, a right side, and an inside. Right?
Can you add
Oh. You could, but there would just be a 0 here. You can never just go, there's too many sides, let me kill him. No, it's going to be a 0 there. That doesn't mean empty space. 0 is not the same thing as a void, right? You're trying to get x by itself. And adding 5 won't get you closer to that. So I add 1, what do I get? Right? Negative 4, 2x, 12. And then what's the last thing? You get x by itself? Divide by 2. All sides. I just do this. And now it's just like that one was, right? So you got your negative 2, you got your 6. What goes with negative 2? What goes on it? A bracket, because you're allowed to equal. You want to include it. Jelly. And what goes with the 6? Parentheses. How do you do interval notation? It's basically done for you, right? Bracket, negative 2, up to 6, parentheses. So those say the same thing. Yes?
I'm going to switch the signs.
Oh yeah, why didn't we switch the signs? At any point did I divide or multiply by a negative number? Nope, I divided by positive 2. Up here I added. So it's only if you multiply or divide by a negative. Then it would switch the signs. Not just that there's a negative somewhere. Aw. Okay. That's nice. Okay. So I'm hoping, if you could solve equations, inequalities, you have to do a few more things at the end. There's that negative thing to be careful about, but they're the same basic steps as solving equations. Okay, so I desperately want to see what you guys already kind of know about graphing. Let me do this. Let me do a quick little something, and then I'm going to give you this worksheet just to see what you already know. So when I only have one variable in my equation, I would use one axis, the real number line for x's. We are working up to, like this, I would graph 1, 2, 3, 4, pop. If it's a single point, we use the circle again for the point. How are we doing? But what if I had x plus y equals 3? I got two variables. They can each change. If that's a 2, what's that got to be? 1. If that's a 3, what's that got to be?
0.
Because together they're supposed to make 3. So there's two directions I can move in. I can change the x's, I can change the y. So I want to give them each their own direction. It's just like an Etch-a-Sketch, right? When I say Etch-a-Sketch, do you guys know what that is?
Yes.
Some of you? It's definitely the older of us. Before we had iPads, we had Etch-a-Sketch. Yay! This is fun, because I don't know about Mike Tyson Punch-Out. So here, I am going to want an x-axis and a y-axis. I mean, the standard thing is it's like latitude and longitude. It's a way of finding points. Now, why do we graph equations? Because very often the graph of an equation has a lot to do with the physical interpretation. So if I throw a ball to somebody, it naturally traces out a parabola. So I can find the equation of that, and then I can graph it, and the graph tells me things. And humans are very visual. So if I write the equation down, people go, But if I do the graph of it, you're like, oh yeah, that's what a ball does. Shit. So being able to graph functions tells us something from the shape of them. But to be honest, how many answers are there to this? How many answers are there to this?
6.
I love you guys. I love you. There's an infinite number of answers. What could x be? What could x be?
1.5.
X could be 2, 3, it could be -7, it could be 18 billion, it could be 1.77777777779, right? There's an infinite number, and for anything I put in for x, there's some y that makes this work. If x is 1.4, y is 1.6. Together they make 3, right? How many ways is there to make 3 from a couple numbers? An infinite number of frickin' ways. So if I ask you for a list of answers, stay with me now. If I ask you for a list of answers to this, you should look at me like I'm insane. Right? I said, I don't get that kind of time. There's an infinite long list. But if I graph it and put little arrows, I say, go to any answer you're curious about, I'm done. Right? So a graph is a visual answer to the question, what are the answers to this? The list would be infinitely long. A graph kind of gives you an idea of the shape of it, like the direction of the points, and then you can just follow the graph to find the point you want. Just follow the graph. So that's actually the most basic reason why we graph, is it's the quickest answer to what are the solutions to this. Right? A list would take forever and ever and ever and ever and ever. All right? So, let me rein it back in. Before we start graphing equations, we have to know how to graph just points, right? Somebody help me out. This is the what axis? I already labeled X, Y. 1, 2, 3, for example. Do these always have to go by 1?
No.
Thank God. Because what if I had to graph 80 million? I'm like, well, okay. I got to break that wall down. So, do you see how this is the normal number line we're used to? And we just put perpendicular to that, so it has its own direction, this other axis, the y-axis. So x controls left and right, y controls up and down. So where would the point 1, 3? So what does that mean? The x and the y, alphabetical order always. Because they don't have to be X and Y, they could be C and D, but unless it says otherwise, it's alphabetical order. So how far are the right and the left or right? Yeah, 1 right, 3 up. So that's that point. So with this system, I can find every point on a plane, right? And latitude, longitude kind of curves that around the surface of the Earth, but it's the same idea. I can find any point on the surface of the Earth using latitude, longitude. It's really just an XY plane put on the surface of a sphere. You guys semi with me? Okay. What about negative 1, 2? What is it telling me to do? Careful. Yeah, it's always X, Y. So back 1 on the X-axis, up 2. Bam. So this is really a series of directions. Go up a block and then go 3 blocks over. Go back a block and go 2 blocks up, right? You guys kind of with me? It tells you how to move around, especially if you live in Salt Lake City, if you've ever been there. Oh my God, they're very full. So let's say, normally I'm going to give it to you like this, so it's easier to grade. Do you see what I mean? You just have a bunch of measles on there. I'm like, oh, which one is which? So what about this one? What about 0, negative 1? Yeah, don't move left and right at all. Down 1. So what do we call this point? This is the point 0, 0. What is the name of that point?
Ground zero.
I love it. Aw. A little memorial there. No. What is it called? Anybody know?
Origin.
Origin. Because do you notice how anytime I'm going to plot a point, I start there, I originate there, and then I move? That's the reason why we call it the origin. Ooh. Right? Maybe. So what point is this then? Careful. Careful.
Negative 3, 0.
There it is. I moved back 3, right? And I didn't move up and down at all. The second one is up and down. The first one is left and right. That's why this one was 0, negative 1, because I didn't move left and right at all. Went down 1. All right. So let me give you this sheet. Try number 1 and 2 right now for me. Get done with them when you try the elements out, but try number 1 and 2 out real quick.